Okay, today is 8/28, 2.1, day 3. We're going to finish section 2.1, day 3. We're going to talk about the domain of a function. The domain of a function is a set of real numbers for which f of x is a real number. The set of real numbers for which f of x is a real number, or y is a real number. In other words, the domain of the function is the largest set of real numbers that produce real outputs. Steps for finding the domain of a function defined by an equation. Start with the domain as a set of real numbers. If the equation has a denominator, exclude any numbers that give 0 as a denominator. Why do we get rid of 0 as a denominator? It is undefined to divide by 0. If the equation has a radical of even index, when you have a radical and this number right here is even, like a 2, like a square root or a 4 or a 6 or whatever, then whatever's inside here can't be negative. If it was the cube root, if it was the square root of -9, or the fourth root of -16, they're undefined. If it's a cube root of -8, it's -2, because -2 times -2 times -2 is -8. If it's an odd index, then it's okay to have negatives. But if it's an even, you can't. So you can't take an even root of a negative number. So let's look at these. So find the domain of a function defined by an equation. And we're going to write it in interval notation or set notation. Set notation or interval notation. You should be able to do both. So this has a denominator. And we're going to write it as x plus 4 over, and we're going to factor this. 3 is 3 times 1. We want a negative, so we put a negative here and a positive here. What can't be 0? The denominator. So x minus 3 can't be 0, and x plus 1 can't be 0. The factors of the denominator, so x can't be 3, and x can't be -1. So in set notation, x such that x is not equal to 3, comma, x is not equal to 1. You can do interval notation if you wanted, but now we're going to focus on set notation. Is there a denominator or a radical? Then the domain is all real numbers, which you can write as -infinity to infinity. That's interval notation. This has a 2. It's an even index. So we take what's underneath the radical, 3 minus 2x, and it has to be greater than or equal to 0. It can't be negative. So I'm going to move the 2x over, and then divide by 2, 3/2. So domain is x, set of all our numbers x such that x is less than or equal to 3/2. You could do it the other way where you move the 3 over and divide by negative, but you have to remember to change the symbol, change the sign to a less than or equal to instead of a greater than or equal to. So denominator or radical, that's what we have to remember. Here, when finding the domain of application problems, we must take into account the context of the problem. For example, when looking for a formula for the area of a circle, a equals pi r squared, it does not make sense to have a negative radius or a radius of 0. So the domain would be r, set of all real numbers r, such that r is greater than or equal to 0. So next we have, when we have f minus g, you write f minus g of x. That's equal to f of x minus g of x. The domain of f minus g of x is the numbers x that are in the domains of both f and g. They intersect. It's the domain of f intersect the domain of g. F plus g of x is f plus g of x equals f of x plus g of x, and it's the domain of f intersect the domain where they have what they have in common when they intersect of g. The product, so we did the difference, the sum, the product, and then we're going to do the quotient, is going to be f times g of x equals f of x times g of x. So it's domain of f intersect the domain of g. And then the quotient, f over g divided by g of x equals f of x over g of x. What's true about g of x? It can't be equal to what? 0. So the domain of f of x is the numbers x